begin transmission. Today we're here to talk about a few species of mammals, those cute, cuddly animals that everyone loves and feels safe and happy with. And I could talk about the glorious, majestic beasts, the rhinos and the elephants and the tigers, but it's often the smaller ones that I find particularly fascinating. I love these little grasshopper mice and kangaroo mice and jerboas that live in deserts and have huge back legs that jump around and giant ears to radiate heat and find their insect prey. And their superpower is their agility. They use their agility to track down prey that's oftentimes venomous, like this one who is attacking a giant ground centipede. And it's so agile it can avoid the centipede's venom fangs, and it gets a nice little crunchy insect meal. What's also really fascinating about this little creature is once it achieves this great victory over this very scary predator, it will howl like a little tiny wolf and declare its superiority over all centipedes in the area. Usually it's a little bit of a high-pitched squeak, but you kind of get the point. Another way this agility comes into play is by avoiding predators. We talked about snakes last time, and certain pit vipers, their venom is specially adapted to destroy mammalian nervous system or blood cells. And so one of the most dangerous predators of these mice are snakes, like this reptile here, this rattlesnake that's hiding in the dirt. And you can see the incredible reaction speed of the mouse to avoid getting bit. It's just remarkable. We slow this down, we see the snake almost get him, but he jumps away and he kind of uses his tail as a little propeller to keep himself in the air and then hops away. Just really remarkable animals and some of my favorite mammals. So we'll talk about 4 others, or maybe 5, I forget, but we'll talk about a few mammals, and then we'll end with a discussion about what it means to be human. The last group of terrestrial vertebrates we need to talk about are the mammals. And mammals are often considered to be the most adorable of all animals. They're often small, cute, and fuzzy, and no arguments here. They are quite beautiful creatures, and with a whole lot of different habitats and lifestyles. And we only have time to talk about 4 of them. So you guys know about the jerboa, or the kangaroo rat, part of the rodent lineage. But we're going to talk about a carnivore, a bat, and then a few primates, and also a monotreme. So try to get representatives of every major group of mammals, but we are leaving out quite a few. First of all, order Carnivora. The carnivores are characterized by eating meat primarily. These are going to include animals like bears and wolves and tigers and a whole lot of other smaller groups. This interesting looking creature here is a nocturnal animal that likes to live in jungle environments. The common name is a kinkajou, which is a great little common name. Scientific name is Potus flavus, and the kinkajou is also known as the honey bear because it likes to steal honey from bees' nests. So it is, it kind of looks like a mix between a cat and a bear and a dog and a monkey, and it's just got a whole lot of traits of a whole lot of different mammals, which makes it fascinating to me. It's nocturnal, so you can see the nice large eyes for being able to see in the dark, and it is primarily arboreal, which means it lives in trees. So it's very rarely encountered. There's not a whole lot of good pictures of this fairly uncommon species, but they're pretty common in their habitats and where they like to eat fruit. So these are frugivores. So they're nocturnal, arboreal frugivores, liking to eat meat at night in the trees. They have a prehensile tail, and they have an extremely long tongue getting at the honey from bees' hives, and they have really powerful claws for breaking open bark to find insects. So they're omnivores, so they eat insects and fruit, even some berries, and they've been even caught scavenging on some dead animals too. So they just kind of eat whatever they can. So this is Potus flavus, the kinkajou, from order Carnivora. This is a fantastic picture because this is just such a strange looking animal. Order Chiroptera is actually the most speciose lineage of all mammals. There are more bats than there are all other mammals combined. So this is an incredibly diverse group, and they look like mammals, but they have these long membranous wings. So their wings are kind of membranes on their hands. So you can see the arm, the little fingers here, and then their wings are basically giant arms and hands. And they're capable of very agile flight, and they like to eat insects and other things. This particular one here, though, before I get too caught up in bats in general, this one is Pteropus. This is the giant flying fox. And this one is a great name because it looks like a little fox, but it flies. Pteropus species sometimes hunt fish, as you can see this one doing here, but they're most well known for eating fruit. So fruit bats or flying fox, and they can get very large wingspans of up to 6 feet, and which is just a gigantic thing to be flying around at dusk looking for things to eat. So it can be pretty frightening. A lot of myths and legends have arisen from humans encountering bats, often because bats like to inhabit dark, musty caves as well. So there's kind of another layer of fear there for humans as well. And when they roost, flying foxes are colonial, and they'll all often roost together in these massive colonies, and they roost upside down, which is remarkable. And the reason they sleep upside down is because their wings aren't actually powerful enough to generate lift from a standing position like birds' wings are, and their legs aren't powerful enough to get a running head start. So to actually fly, they have to fall to generate enough speed to actually fly. So hanging upside down lets them, as soon as they wake up, they can release and let go and start flying. It also gives them a quick way to escape predators. The bad thing about sleeping upside down is young bats always pee on their faces because they don't know not to. And so if you watch a young bat as he grows up, they will eventually learn to kind of do this backwards somersaults when they have to pee, and then they pee and then they go back up to hanging upside down. So they eventually learn not to urinate all over their faces, but it takes them a while to figure that out. The other thing I want to say about Pteropus is that they're incredibly intelligent. They have one of the largest brain to body mass ratios in the animal kingdom, about the equivalent of a dog. So these are very intelligent creatures, and they can create mental maps of their area and remember where good sources of food are for many, many years. So they're very good at finding places and exploiting new resources and problem solving. Because they fly so much, flying generates an enormous amount of heat and requires an enormous amount of energy. So they have to eat an incredible high efficiency diet, which is why most of them are insectivores or frugivores. Flying foxes aren't insectivores, but you should also know bats are famous for their sonar, which uses sound bouncing off objects to generate a map of their environment. But flying foxes don't use that because the fruit doesn't really fly away. And then the last thing I want to say about bats is because of their high internal temperature, their internal body temperature is often normally at well over 100 degrees Fahrenheit. So these bats make really good reservoirs for a lot of viruses that are very damaging to a lot of other mammals, because usually a mammalian body, when they get infected by a virus, they ramp up a temperature to kill the virus, but viruses that live in bats are kind of used to those high temperatures, and so the bats harbor a lot of viruses that don't affect them very much because of their normally high body temperature, but when they pass over to humans, they cause a lot of problems. So this is Pteropus, the giant flying fox, intelligent, roosts upside down, eats fruit, high body temperature, and a good reservoir for viruses. Monotremes are strange animals. They're in class Mammalia, but they have attributes of almost reptilian ancestor-like creatures. So monotremes are animals that lay eggs, even though they're mammals. They lay these kind of leathery like eggs, and then when the little babies hatch, they're very altricial, which means underdeveloped. They require extended parental care, and but they do lactate, and they do have hair, so they have attributes of mammals and attributes of other animals as well, which makes them a really unique group. There are only a few species. The Zygossus is the long-beaked echidna, and there's also duck-billed platypus, the more famous member of this group. But Zygossus, the long-beaked echidna, you can see some of its hairs are modified into little spines for protection. This is primarily a nocturnal animal, but you notice its eyes aren't really well adapted to the nocturnal environment. So eyesight isn't very important for this creature. Rather, smell is going to be really important. They're really good at smell. Their long beak has special sensors on it that can detect the smell and movement of earthworms and other insects, invertebrates that they like to eat. So they live in burrows during the day and then wander around at night, scuffling up some earthworms to eat. Very adorable little creatures, right? I would like to have a pet echidna. So Zygossus is the long-beaked echidna from the very strange order Monotremata, which lay leathery eggs but lactate their young and have hair. In order Primata, this is going to include the monkeys and the apes and the lemurs and this little creature here, the slow loris, which is just a very unusual looking animal. It's called the slow loris, genus Nycticebus, because it moves very slowly and deliberately through the trees, often using all four limbs at a time. So it tries not to disturb a single branch and just kind of melts into the trees to escape predators. So the slow loris kind of looks a little creepy. That's maybe a little better of a picture, but they're just very strange animals. Their giant eyes can tell you that they're primarily nocturnal, and they like to eat insects, so these are nocturnal insectivores. They have special defense mechanisms. They have this gland in their armpit called a branchial gland, right, as their arm branches off from their body. And this branchial gland is a scent gland, and they will rub this scent on their fur and on the fur of their babies. They will use it to mark their territory. So smell is very important for these guys, and most of the communication they do is via smell. And also this little branchial gland, this little armpit secretion, if it's mixed with saliva, then it turns into a pretty potent venom. And so when they're really seriously threatened, they will secrete some armpit gunk and then put it in their mouth, mixed around with saliva, and then bite their predator. And then it'll latch on really strongly and tightly. They won't let go for a long, long time to get maximum transfer of venom, which is very disturbing. So a little armpit juice venom on these slow lorises, which is a little creepy. But they can also be kind of cute. Look at this little guy. He's got two little rice balls. He doesn't know what to do with the third one, but he really wants to eat it. Poor little guy. Also, when they get scared, their initial reaction is to put their hands over their faces. So sometimes they're called shy monkeys, which is pretty adorable. And then these guys, also in order Primata, this is Homo sapiens, the human. And humans are really unique animals in that they are bipedal. They have very little hair. They have a lot of sweat glands. They're good at running. They're good at throwing. And they are highly intelligent. So humans are incredibly social, obligately social animals. And as when most animals are social, you see a corresponding increase in intelligence. So some of the most intelligent animals on Earth are always the social animals, from insects to whales to birds and humans. If you live in society, then you kind of require an increased level of intelligence. So humans are the best animals at problem solving and abstract thinking. They can communicate with abstract symbols and language, highly developed language. The brains are the most complex of all the mammals, and they have invented or believe in or were created with the concept of religion. So mammals or humans are unique morphologically by being bipedal, relatively hairless, with lots of sweat glands, and really good runners and throwers. Not a whole lot of animals can throw a baseball, right? That's kind of that overhand motion is kind of unique to humans. But also more abstractly than our morphology, we, or humans, have advanced levels of cognition, problem solving, intelligence, abstract symbolic language that's used for complex communication, and religion. And I think it's really the religious aspect, the knowledge of the divine, that really sets humans apart from other mammals. But this leads to some really interesting questions because kind of deep in every human's heart is kind of a thirst for immortality, for something beyond the physical, for something spiritual. And kind of out of the overflow of this, humans created androids as kind of a way to advance technology, maybe to a point where humans could live forever. Maybe we could transfer a human consciousness into an android body and get rid of this deteriorating organic forms. And that's what happened slowly over the course of the last 1,000 years or so. Particularly, there are some tremendous advancements made in the 24th and 25th centuries as androids became more and more advanced and complicated, and their internal systems started to generate their own novel consciousnesses. And this led to some really important debates. Some humans thought that we should give androids equal rights, and some humans thought that we should just treat them as machines. But that distinction became more and more blurry the more and more complex the androids became. And eventually the androids themselves began debating this, both with humans and with other androids. And within the past 400 years or so, the balance of power definitely shifted over to the androids. Some people actually consider some androids consider Homo sapiens to be a lesser species, and so they prefer to call them Homo inferioris, and the androids Homo superioris. But most of the more moderates among us consider Homo sapiens to be kind of the organic, original human, and the androids are Homo technologicus, the more complex and not completely organic kind of future humans. But the question I want to really get to is from a theological perspective, from a religious perspective, what are these androids? So as you know, I believe in God, and I believe that God created humans, and I believe that God created humans the way the Bible communicates that He does. And the way the Bible communicates God, the Trinity, created humans is by creating them in His image. He created males and females as relational beings in the image of God. And so what is the image of God? Historically, this has not been considered to be morphology, right? It's not, we're not in the image of God because we can throw a baseball, or because we sweat a lot, or because we have 5 fingers, right? I don't think God, an immaterial being, has those morphological features. Which means, so what is it? What is the image of God? Do humans have it? Do androids have it? Why or why not? And so I think the image of God has to be something more about the function of humans in this world, why God put humans in this world. For one, for relationship. Well, actually, for 3. All 3 are about relationships. Firstly, a relationship between the Father and the Son and the daughters. So the relationship between humanity and the divine, I think that's part of the image of God. Because God is relational, humans have to be relational. Secondly, the relationship between us and other humans is also relational, and so we have to treat each other with the character of God. So kindness and compassion, integrity and selflessness, love. And that, when we do that, we are fulfilling the image of God. And then thirdly, I think the image of God has to do with our relationship to nature itself. So 3 things: relationship between humanity and God, between humanity and each other, and between humanity and nature. And I think one of the distinctive aspects of the image of God, the image-bearing animals that humans, and I would argue androids are, is how we take care of nature. And so we've talked about intrinsic value, relating that back to the Trinity, and kind of how to navigate the difficulty of animals that harm humans and other animals and ecosystems, and how to deal with that complexity. But being in the image of God, I think, gives humans higher intrinsic value. And at the same time, part of our responsibility is to take care of the things that God has given us. So I would argue, as a modern third millennial Christian, that the image of God is not morphology. It is more about relationship between humans and God, between humans and each other, and between humans and nature. And therefore, are humans and androids really all that different as far as bearing the image of God? I would argue that androids too bear the image of God. After the disastrous events of yesterday with the tragic deaths of Master Sergeant Rush and Dr. Arnold, one thing was immediately apparent to the members of the crew. And that was 4 people ate dinner, 2 people died, and 2 people did not die. So suspicion was immediately cast on myself and Charlie. And so to get to the bottom of this, we investigated what was it about the food or the meal or Rush and Arnold that Charlie and I were safe and they were killed, because it certainly wasn't a poison that I administered. I would never do such a thing, and Charlie, of course, would not either. And it turns out that after some wild accusations were thrown and things got a little heated, we figured it out. A trachotoxin is developed by the funnel web spider to incapacitate its invertebrate prey, and also through as you know, through an unfortunate series of convergent evolution, the nervous system of primates and the nervous system of the insect prey of the funnel web spider are similar. And so what affects one affects the other, and vice versa. So the atracotoxin only affects primates. And that is why Charlie and I were spared from death, because we're not primates. Being the 2 ships' androids, we don't have the same neurophysiology as the rest of the crew. And so the atracotoxin apparently doesn't affect us, even though it drastically affects the primates on board, the Homo sapien members of the crew. And now what follows after that dramatic reveal is a melodramatic memory montage of little bits of clues that I have lovingly crafted and placed throughout the last few weeks of lectures to lead up to this spectacular moment. It is the year 3020, and we have instant genomic sequencing, and I have a super advanced future brain. Charlie is a next generation model, as you could say. One of my favorite memories of growing up around the turn of the 29th century was going to the beaches around Knoxville when I was a kid. Captain and I are both veterans of the first and second android-human wars, or as he likes to call them, the wars of android aggression. There were good people, good androids on both sides of the war, but the captain and I found ourselves on opposite sides, and his side lost. I wouldn't approve of her relationship with Charlie if I didn't think she had a high character. Although I don't approve of their relationship for some reasons. It's very complicated, and the captain is quite opposed to their being together.
It's very complicated.
And as the ship's androids, Charlie and I, our job is to collect a lot of data. We can process data a whole lot faster than everybody else, and prepare this planet for your potential voyage here. And it's important to have these androids here because this creates a continuity bridge between the first crew and the next crew. It takes 51 years and for the next crew to get here, even longer than that because we have to wait for the right time when all the stars are aligned, so to speak. The human members were always going to eventually die before seeing the next wave. That was kind of what they signed up for. Most of them knew the risks and expected to die of sudden acute onset deep stasis sickness, or SADS. And so I was always expecting to be kind of alone here with Charlie until you guys got here, but it's becoming increasingly likely that we will be alone here much more quickly than we were at first expecting.